Hello and warm welcome to another Junior Taki production. In this video, we're going to be looking at how to factorize trinomials, also commonly known as quadratic expressions. Let's get straight into it. We are required to factorize the following expressions. Part A, you are given x squared minus x minus 6. You recall from grade 9 when you dealt with factorization of trinomials that you need to find factors which when you multiply, they give you the value of your constant term within that given expression. In our context, the constant term is minus 6. So we're looking for two factors of minus 6. The same combination of factors, when we add them, they must give us minus 1. Where is the minus 1 coming from? It is the coefficient of x from our original expression. Now, those two values immediately should recognize that they are negative 3 and 2 respectively. If you multiply minus 3 and 2, it gives you negative 6. If you add minus 3 plus 2, it gives you minus 1. These two conditions must be satisfied all the time for you to get true factors. So when writing your answer, you're going to get the two factors as x minus 3 and x plus 2 making up the second factor. We move on. We are given part B, 6x to the power 3 plus 17x squared plus 12x being the given expression. Although it doesn't look like it's a trinomial, but what is most important, if you know your rules of factorization, is that there is a common factor of x throughout the three terms that make up that expression. So you need to take out your common factor first, which is your x. Then you're going to remain with 6x squared plus 17x plus 12. But now what remains is indeed a trinomial. So we need to factorize that trinomial 6x squared plus 17x plus 12. Now to factorize that, we're going to have our two brackets made up of 2x in the first, and you're going to have 3x in the second bracket. Where is the 2x and the 3x coming from? The factors of 6x squared, that 6x squared would be your 2x and the 2x. Then finally, the last term, your 12, you get it through saying 3 times 4. So that 3 and that 4 will give us the 12. So these are our two factors in their correct order. We move on to the next question. We are given m to the power 4 minus 7m to the power 2 minus 18. Although it looks complex, it looks like it's a big power, m to the power 4. The concept is the same here. Some would choose to say, let x be equal to m squared, but I'm not going to do that. I'm going to go straight into it and just say, in the first bracket, we get m to the power 2 plus 2, and we're going to get m to the power 2 minus 4, minus 9 in the second bracket. Notice again, in the second bracket, in your second bracket, there is a difference of 2 squares there. Remember, you need to check to see if your factors are fully factorized. M squared minus 9 is not. It's a difference of 2 squares. That means we're going to get m to the power 2 plus 2 as our first factor, but we're going to have two more factors. That is your m plus 3 and m minus 3, giving us the last answer. We move on to part D. Part D, you are given in bracket x minus 5 to the power 2 minus 5x minus 5 plus 6. Again, you might want to treat the x minus 5, you may equate it to y, should you choose to. You're going to have y squared minus 5y plus 6. But I'll move straight into it, and I'm going to get my two factors as x minus 5 minus 3, then I'll have x minus 5 minus 2 as my two factors. One might wonder where I got the factors from. From that x minus 5 squared, it's as a result of multiplying x minus 5 and x minus 5. And to get the factors of plus 6, which when you add, they must give us the coefficient of the middle term. In other words, the factors of positive 6, which when we multiply, they give us minus 5. The two factors would be minus 3 and minus 2. If you add minus 3 to minus 2, you get minus 5. If you multiply minus 3 times minus 2, it gives you a positive 6. Thereafter, we just simplify by removing the square brackets. We're going to get x minus 8 and x minus 7 in the second bracket. I hope you're enjoying that. This is Mr. T signing out. Bye-bye.